Hello and welcome to Geometry with my mom. This is my mom.
Hello.
And let's begin. So today we're going to be talking about translations. And specifically we're going to be talking about translations in terms of these new things called vectors. Now if we've got a point that is right here, our point A, 2, 6. Let's say we want to move that point down to here for a new coordinate of 7, 2. This is what a translation really is. We can make a new A prime by shifting, just moving over. Doesn't have to be over reflection or necessarily in relation to a line of reflection. It just has to be in a certain direction, a certain distance. Okay. So, we doing good, Mom?
I'm not sure what you just said, but I'm trying.
All right, we'll get there. So if you look at the distance that we've got between A and A prime, we'll see that we're moving down. If we're at 2 along the x, we've got a distance of 5 that's separate along the x between 2 and 7. So we're going to see that we've got a movement horizontally of 5. Yeah? And to get down, we have to move 2, 3, 4. We have to move 4 to get to our new point of A prime. And so this is 4. What we can do is we can combine this horizontal and this vertical direction into a vector. This is our vector right here. And the way we're going to describe it, instead of using parentheses, we're going to use some kind of pointy brackets here. First we're going to describe our movement along the x, which would be 5. And then we describe our movement along the y, which is 4. Again, it looks very similar to how we might describe a coordinate, but we're using the pointy brackets to make it different. So let's see how this would work for another point here. If we've got this point, let's say B. We've got B. What are our coordinates for B there? So we got
3.
We're 3 up along the y. And our x, how far are we going horizontally?
To get what?
To get to B.
Oh, it's there. Oh. 1, 2.
Whoop, whoop.
Oh.
Just from here. So.
Oh, up and down.
Mm-hmm. Or how far left and right do we have to go to get there?
Left 1.
Oh, no, right to that point right there.
From where?
From here. This is our 0, so we've got a 1 right there. And we take it on up.
3.
That's the 3 we've got that go up and down.
Okay.
And to go this way, we go just
1.
1. So we've got our original coordinate here of 1, 3. And if we want to move this along a vector, let's say of -2, and let's do -2, 3.
Okay.
So we're going to take it 2 in the negative direction, 2 this way. So, Mom, where would that end us up? we're just going to chew to the left. Just start off at our point B.
Oh, here. Right there?
Oop, don't forget to count this guy.
Oh, wait. 1. Oh, right there, 2.
Okay, 2. So this is the first step. This is the horizontal component. Puts us right there. A little 2.
Okay.
We're going actually -2. Let's be specific. And now we've got to go 3 up from this spot right here. So where's that going to put us?
6?
Yep. Okay. So we start at B. We're going -2, 2 in the negative direction. We're going up 3, because 3 is positive. And we've got our new point here, B prime, which would be -1. And then we're adding 3, 6. -1, 6. Now, the beauty of this is that we've got our original point here, this 1, 3. And if we add our original point along with the coordinates of our vector, we're going to get something very useful. So we're keeping these separate. We're going to get 1 plus -2, which gives us
-1.
And then we get 3 plus 3, which gives us
6.
6. Put a comma between them, put some parentheses around them, and our original point plus our vector gives us
Oh, same thing? Oh.
B prime. Okay. So we can use the graph to figure this out, but we can also do it numerically as well. Okay? That's because every vector has 2 things. It's got a magnitude, so it's got like an amount of the distance that it's going, and it's got a direction. So our vector is actually going to, we broke our vector into kind of pieces here, but the vector itself would be this guy right here. It's got a magnitude, it's got a length, and it's got a direction. It's going off. We can actually measure how far that is going in terms of degrees. Vectors have magnitude and direction. Let's practice applying another vector here. We'll do it graphically and numerically. So let's start with a point right here. Let's do C. And the coordinates for this point would be 1, 2, 3, 4, 5, 6. So we're at -6. And vertically we're at 1, 2, 3, 4, 5, 6. -6. -6, -6.
But you put parentheses there.
Because this is a point. The point is different from a vector.
Oh,
We're going to apply the vector here. Last time we did the graph first. Let's take a look at where we expect this to end up numerically. So let's take our point -6, -6, and let's do a vector. Let's try 4, 7. Oh, whoop. Pointy brackets, pointy brackets, pointy brackets. Alright. So like we did last time, let's add our coordinates to our vector. So the -6 plus 4 gives us
-2.
And the -6 and the 7 give us
+1.
+1. Got the comma between them. We make this into a set of coordinates. So this should give us our C prime, which is a translation, a slide of our original point here, C, to our C prime, -2, 1. So we go -2, 1. This should be C prime at -2, 1. Let's see if it checks out. So we should be moving to the right 4. 1, 2, 3, 4. Looks like that lines up correctly there. So our horizontal movement along the x-axis looks like it's doing well. And we're going up 7. 1, 2, 3, 4, 5, 6, 7. And we're at the spot. And the vector itself is going to look like this. It's got a magnitude, it's got a length here. Okay, if we were to measure it out, we can figure it out via the Pythagorean theorem. But it's got a length and it's got a direction. And we can describe that vector right now in terms of, again, that 4, 7.
What do you use this for?
If you're looking to move things very precisely, especially if you're looking into something like engineering or anything involving computers, you've got to have that precision. And you can also do that in 3 dimensions as well. So when you're getting into stuff like physics, there's the x and the y, and then there's a 3D component, so that there's a z. And then you've got vectors that are like going in all sorts of different directions. You can combine them, you can add them together, but that gets into a little bit more advanced math.
So if you're going to take physics, you should take calculus first?
They're good to have together. But you can do a lot of physics even without calculus.
Can I just tell them I won't be dancing?
You won't be dancing? Oh, no. Oh, that was another class.
Oh, another class?
Yeah,
Okay.
yeah. They haven't seen me dance yet.
Oh.
I think they're thankful for that. Mom, let me give one to you here. So, if I've got a point right here.
We got a lot of film.
Alright. So, let's say this is D. And our point here is 1, 2, 3, 4. We're at -4. And we want, and our y is 1, 2, 3. 3. -4, 3. If we want to take -4, 3 and move it a vector of, let's say, 6, -1, where would that end up?
Negative. This is regular 6. But I'm using this line first.
We can do it numerically too. We can either do it graphically or numerically. So,
which way you want me to do it?
Whichever way you feel more comfortable with. If you want to do it numerically, you can set them up. You can just add them together, or you can count it out.
Okay. If I was gonna, this would be over here for 6.
We have to add it though. It's not a point. It's a change in points.
Okay, so I take the 6 and then I subtract the 4, -4.
We can set it up like we did with our past ones, right? So we're just adding them together. We'd set them on top of each other if we want to do it like that. So our point is -4, 3.
Here?
Sure. So put parentheses. -4, 3. Close parentheses. Okay. And put a line underneath because we're going to add those together. Okay.
Okay, so -4 plus 6 gives us a +2. So I just put 2, comma, and then a 3 with plus -1 gives us another 2, right? Do I put anything around those?
Yeah, let's put some parentheses around it because this is a new point. What you get at the end is going to be a point.
Okay.
So you're saying that our new point, our d prime, which is translated or moved along a vector of 6, -1, is going to give us a point of
2. 2?
Mm-hmm. So let's see, where would be 2, 2 be here?
Is this 1? So that's 2?
Yeah. Yeah, that's, we got 2 vertical, and don't forget the horizontal. Where is it going to be horizontally?
2.
Mm-hmm.
So we're, you got these squares as each one?
Yeah, so each
Right
line.
here?
Yeah, there we go.
Dot?
Mm-hmm. And that's 2, let's label that. That's 2, 2.
Underneath it?
Uh-huh,
Or
sure.
in parentheses?
Uh-huh. Okay, and then we're going to label this one capital D prime. It's a capital D with a an apostrophe afterwards, like that. Yeah, there we go. That's it. And does
Okay.
this work? Let's see. We're moving at 6, -1. So we go 1, 2, 3, 4, 5, 6. So it looks like it checks horizontally.
Mm-hmm.
-1. We're moving 1 in the negative direction, so 1 down. There we go. And we can draw in our vector, just to make it very clear. And this vector, as we said, this vector is 6, -1. 6, -1. And that's it. That's how we move things. We make translations from a pre-image to an image using vectors. We've got an x and y coordinate. We know that these are vectors because they've got the pointy brackets around them. And we know that each vector has a magnitude, that's an amount, a length, if you will, but it's a number, and it's also got a direction. And that's what makes a vector, and that's how it's different from just a point. It has a magnitude, an amount, something we can measure, and a direction. And that's translations by vectors. Feel good about it, Mom?
Oh yeah. And this is geometry.
This is geometry.
Well, it's a lot different than when I was in school.
Can we ask how long ago that was?
About 47 years ago since I've had this.
Alright.
Things
So-
have changed in the math world.
But my mom absolutely did vectors perfectly well here, excellently. And if she can do it, I have the absolute utmost confidence that you can do the same. So
I do
practice
too.
this, practice this, and we will be talking more about it. Alright? Have a great day.
Nice to meet you all.